Hello everyone, Aaron here, and welcome back to Leetcode. Today we are solving the shortest unsorted continuous subarray problem. Let's dive right in and have a read of the description. Given an integer array nums, you need to find one continuous subarray that if you only sort this subarray in ascending order, then the whole array will be sorted in ascending order. Return the shortest such subarray and output its length. So here we see nums 2, 6, 4, 8, 10, 9, 15. So we can see here that 2 and 6 is fine. 6 and 4 is out of order, so they definitely need to be in the... One of those... Well, yeah, no, they need to be in the subarray to sort. And then we keep going. These 4, 8, 10 are fine, but 10 and 9 is bad. They both need to be in the subarray to sort. But the 9 and 15 is okay. So if we sort those, we're okay. That's 5 numbers, so we return 5. Here we have 1, 2, 3, 4. They're already in order, so we don't need to return anything. 1 is already in order, so we don't need to return anything. I'll be honest, it feels like all we need to do is find where it's out of order. Is there more to it than that? So if we find the first pair that's out of order and we find the last pair that's out of order and take those two, so that would be 1 and 5. 5 minus 1 plus 1 is 5. Is there a way that could go wrong? If we have 1, 4, 9, 2, 3. Those two are out of order. Ah, no, hang on. What happens if we have 3, 4, 9, 2, 5? So those two are out of order. And no, in fact, no, it's just those two that are out of order. But we actually need to sort all of them to end up with a sorted array. So when we find the things that are out of order, we actually need to extend the range so hang on, they're out of order, 9 and 2, so we need to find the range wide enough of all the values to hold the 9 and the 2. Okay, so if we go here, 6 and 4 and 10 and 9, the 4 is the smallest out of order thing and the 10 is the largest out of order thing we've found. So we need to find the sub-range such that 4 and 10... Yeah, we need to find the index where everything is less than 4 and the index where everything is greater than 10. And then the range we need to sort is in between those. Okay, I think that might be the algorithm we actually need to do here. Int low out of order is -1, int high out of order is equal to -1. 4 int I equals 0, I is less than num size minus 1 here because I don't want to go all the way to the end because I'm checking the pairs. And what I want to do here is compare nums I with nums I plus 1. So if nums I is greater than nums I plus 1, out of order, so if low out of order is equal to -1 or nums I plus 1 is less than nums low out of order. Low out of order is going to equal I plus 1. So that's the case here where we find the 4. The 6 and the 4 are out of order. The 4 is the lower one, obviously. We know that. Now we haven't found anything low out of order yet, so we're just going to set that to be this value here. Else, in fact, what we're going to do, we're not going to make that an else. If high out of order is equal to -1 or nums I is greater than nums high out of order, high out of order is equal to I. So now, by the time we sweep through these, low is nums low out of order, or in fact no. If low out of order is equal to -1 or high out of order is equal to -1, return 0. So if we're at the -1 case, we're done. Otherwise, we know what the lowest value we need to contain is. High is nums high out of order. So this is where we need to sweep across and find the position where our lowest out of order should go. And I equals 0. I is less than nums size I plus plus. In fact, no. Int low position we're going to call 0, and then what we're going to do is we're going to do while low well, first off it's going to be low pos is less than nums size, and nums low pos is less than low pos plus plus. And then we kind of want to do the same thing for the high position. High position is going to start at nums size -1, while high pos is greater than or equal to 0, and nums high pos is greater than high pos minus minus. If that's fine. Then all we want to do, so here when we're sweeping the 4, we would have got low position started at 0. 0 is less than what is that? 3, 6, 7. And 2 is less than 4, so that's good. Goes to 1. But here we would have stopped because 6 is greater than 4. In fact, that may need to be an equal sign. No, we'll make it strictly less than. No, we'll make that equals. So 6 is greater than 4. So low pos is not going to increment anymore. So we found the 1. And on this end here, we're looking at position 6. 15 is greater than 10. But 9 is not greater than 10. So we're going to get this to 5. 5 and 1, we want to return high pos minus low pos plus 1. So running through it from the top with our numbers here, we're going to find initially low out of order, high out of order. These are going to start at 0. No, they're going to start at -1. -1. So we're going to sweep through. 2 and 6 are in order, so we don't do anything. So don't need that comment. 2 is not greater than 6, so we don't do anything. 6 is greater than 4. This needs sorting. If low out of order equals -1, it does. Low out of order is going to be 2. 0, 1, 2, because this is I plus 1. High out of order is -1, so it's going to get set to I, which is 1. Then we're going to keep going. 4 and 8 are in order. 8 and 10 are in order. 10 and 9 are out of order. 0, 1, 2, 3, 4. So low out of order is not -1. And 9 is not less than 4. So we don't do anything with the low out of order. High out of order is not -1. But 10 is greater than 6. So we're going to update high out of order to be 4. 9 and 15 are in order. So this is the first phase done. So now we set, well, no, first we check, are they both -1? No, they're not. Low is 4, high is 10. We're just reading those positions out. So now we're going to go low pos and high pos. Low position is going to start at 0. High position is going to start at 6. So we're going to only iterate 0 to begin with. Low pos is less than num size, or 0 is less than 7, yes, and num's low pos is less than low. 2 is not less, 2 is less than 4. So this gets incremented. 6 is, well, 1 is safe index. 6 less than or equal to 4 is false, so we stop. Now we're going to do the other one. High pos is greater than or equal to 0. It is. Num's high pos is greater than high. 15 is greater than or equal to 6. It is. So this comes down. Sorry, greater than or equal to 10. We go around again. 5 is greater than or equal to 0. It is. Num's high pos 9 is greater than or equal to the high value 10. It isn't, so we stop. And now we're going to do 5 minus 1 is 4 plus 1 is 5, returning 5. Right. Let's go around again with a different example. What was the one we had before? 2, 3, 9, 1, 5, I think it was. Low out of order is -1, high out of order is -1. 2 and 3 are on order, 3 and 9 are in order, 9 and 1 are out of order. So we're going to set the low out of order to be I plus 1, 0, 1, 2, so that's going to be a 3. And this is going to be a 2. Just because they're both -1s, they get set to I plus 1 and I respectively. 1 and 5 are in order and we're done. So low and high are now set. They're not both -1s. So we're going to set low is equal to 1. High is equal to 9. So now it's low pos and high pos. These are going to start at 0 and 4. So 0 is less than 5, but 2 is not less than 1. So we stop. 4 is greater than 0. 4 is greater than 0. But 5 is not greater than or equal to 9, so we stop. 4 minus 0 is 4 plus 1 is 5 because we need to sort all 5 items. Excellent. I think this might work. Let's click run code, partly as a syntax check. That seemed to work great. Let's use all the example test cases, just in case I've missed something. No, looks good. All right, let's click submit, fingers crossed. Hey, we got it. Fantastic. Runtime 38 milliseconds faster than 60%-ish, and we use less memory than about 40%-ish. Both of these strike me as incredibly middle of the pack. We probably could have improved things in these loops a little bit, tightened them up, but this is pretty readable. I'm not too upset with this. It does its job nicely. I think we'll leave it there for today. Thank you very much for watching, and I will see you all tomorrow. Bye.